Hi there, welcome back to Atrocraft. Today we're doing another unscripted tutorial, this time diving into the closed loop feed systems I showed in a previous short. These systems are incredibly flexible. They can take any number of inputs and support any number of machines as long as your per minute values are in the ballpark. For when they aren't, the loop can actually self-balance and distribute items much more evenly than a traditional manifold. So without any more delay, let's jump right back in and break down exactly how these work. Okay, so what is a closed loop feed system? This is a configuration I set up that it's kind of like a manifold. If you can imagine multiple manifolds strung, in a row, so the end of the one manifold is feeding into the next, and then the last one is looped around back to the beginning. So it's a sort of like a expansion on the manifold system, but it's self-balancing and it can take any number of inputs. So let me show you exactly how this comes together. These are the copper powder recipes. I'm using this because I have easy access to copper right here, but also partially because the math is not exactly going to work out here perfectly until we do some tweaking. So these each they're really 780, but let's just say 750, right? And each constructor wants 300 a minute. So 750 is going to be, 2.5, right? And we obviously can't shove a merger right in halfway into the constructor, so we're going to have to split it into sections of 3 and sections of 2. So let's do that right now. I'm going to use these smart splitters, but initially we'll just configure them like they're not smart. And I'll show you what this setup looks like when it's not perfect, because it still does a pretty good job. So right here, this is just a normal manifold, right? But if we take some priority mergers, we're going to need one at the end, one. So this, if you can imagine, this is where we're splitting it up into the multiple manifolds, right? So this would be 1, 2, 3, and 4 right here. Okay. So if this was one manifold, this would require 900 a minute, right? And then this one here, the 2, would require 600. So this one would be underfed, or this one would be underfed, this one would be overfed, under, and then over. All right. Bring these down, and we'll start getting these in. Actually, no, we can't do that yet, because we missed the last step here, which is Get a lift at each end here. And then put one there. I think this will be long enough. I don't think we need a ton of these. Where was that other one? Here it is. Bring it all the way back. Feed it right back into itself. We'll connect all the rest of these up. Okay. Now these smart splitters need to be initially configured. So to make them act like dumb splitters, we'll just set them all to any. This one is not connected. There we go. Good. Seems like they're all connected, all feeding in to each other. Let's get some of these throughput monitors. Let's get some of these on here so we can tell exactly how much we're drawing. And then one there. I think I already have one on this end. This is the second take of this. The first one, the audio was not great, so sucks when you have to redo it, but it's all right. Okay. I think these should, yeah, the short side should be hover around 660 like they are. And these are 530, 540. And then, like expected, the third one and the eighth one, 1, 2, 3, yeah, the eighth one, these will only be running half the time, just because of the nature of this smaller manifold, right? So like if we said before, if you imagine this section here as a smaller manifold, it's asking for 3, 6, 900 and getting 750. And because we're not programming the splitters yet, it's actually not even getting that much. Or, well, it possibly is when you add in what it's getting from the other side. But still, the output is only 400 right now. So you can see the system, it is self-balancing because of the items being sent back. It's not quite running at capacity, but you know, it's not too bad for what it is. If you wanted to set up a system like this before you had the smart splitters and the priority mergers, that would be fine, you know. And then commit to going back to fix, you know, to get them in later. Or, I mean, it also wouldn't be an issue if we just set up an extra, so if these were 12 constructors split evenly into groups of 3 each, then that would be fine. Then you would have an overage of building capacity than what you're feeding, right? But let's see if we can fix this a little bit. First, let's change these to overflow on the center and none on the right. Which the right's not connected, so really need to do that, but will anyway. So now the splitters are trying to send everything it can into the machines. This will improve our input numbers. Because, like, say this last one in the row here, it's no longer trying to shove items down the row as often as it was. So you see we're still sending some items back. Not as much as before, but there's still going to be a constant trickle. And what this indicates is that the system is not balanced somewhere. 416, getting another 15 a minute out of it. Not perfect, but 436, yeah. 500 is the perfectly sized and balanced system. We're definitely taking in a lot more input. And we're seeing a lot more consistent green across the board here. But now, to really get it dialed in perfect, we need to do this. We need to set these values to there you go. Now 250 a minute it's asking for. 250 times 3 is 750, so the input value is balanced with the value that it's expecting. On these, we can't quite do that. We have to set this to 125 and overclock it. Now they'll read 375, but again, 375 times 2 means 750. And if you didn't want to overclock, you could do like I said before and just have 3 instead of 2. And that would balance it the same way. Now, see already our inputs seem a lot more consistent, right? We're still sending a couple items back, but over time that will disappear. And look at that, we're already hitting 5. Let me just reset some of these inputs here. What this will do is it will make it balance faster. There we go. Now that 19 will go to 0. Now you could say to yourself, if the system's balanced and it's sending nothing back on the return line, do we even need it? And technically, no. At this point, we wouldn't. But not everything works out perfectly all the time, right? What happens if one machine gets turned off or gets backed up? Then you would still want the rest of the system to be able to self-balance however it can. And you also would like to have this here as it's a very quick visual indicator that something somewhere is off, right? There you go. Now these are reading 780. That's because I pulled all the items. But as they back up, these will all come back down to 750. That will stay at 0. And this side will be pretty much locked at 500. It'll fluctuate, you know, a little bit. 10 over, 10 under. What this does is it averages over a minute, right? So, and then this cycle is 4.8 seconds. That's pretty good. But still, it's not, you know, the production is not in sync, at least not enough to get a perfect value out of here every time. So, is what it is. There you go. Already, these numbers are coming back down. Well, we're sending some stuff back. That should go away. Let me just check these to be sure. 125, 125, 83, 83, 125, 125, 83, 83, 83. Strange to see these coming back. But I mean, it is the system working as it should. Alright, so near the end here, you'll notice I was trying to figure out why the system kept passing items back into the loop, even though everything looked correct. And off camera, I finally figured it out. The surplus was coming from the difference between a full Mark V belt, 780 per minute, and the 750 per minute I actually sized the system for. So even though the producers were balanced, the belt itself was carrying a little extra every cycle, and the leftover had nowhere to go except back into the loop. Once you understand that mismatch, the behavior makes perfect sense. Closed-loop systems are self-balancing, but they're also perfectly honest. They'll show you every little overproduction, underproduction, or belt mismatch, whether you plan for it or not. Anyway, that's going to do it for this one. If you found this helpful, hit like, drop a comment, and don't forget to subscribe for more factory design tips and long-form tutorials. Thanks for watching, and I'll see you in the next one.